Okay, so this is the other way of separating liquids. This is paper chromatography. And usually they're going to be separating components of dyes. So if you have black ink, it's not really black. It's got a whole bunch of different colored dyes in it. The idea is you start like over here, and let's see if I can make my pencil work. You start over here with an ink spot, placed on this piece of chromatography paper, and the bottom of it is stuck down in a solvent. Usually the solvent is water, but the solvent could be something that is nonpolar. And the solvent travels up the paper, and as it does, it separates out the different dye components. Okay, so a couple of different things. The paper is called the stationary phase. Stationary, it's written over here. Stationary. And the solvent is called the mobile phase. They can be, one of them will be polar, one will be nonpolar. They will change it up on you. Usually, the paper is considered nonpolar, and the solvent is water, which of course is polar. If you look over at the right-hand beaker over there, you can see that the dot that was originally purple, kind of purple, over there on the left is now faded out, and it is broken into these 4 different dyes. So let's say that the paper that we're working with here is nonpolar, and that the solvent is water, which is of course polar. The idea here is that the nonpolar guys are going to get out of the polar water as quickly as possible and connect onto that nonpolar paper. So red would be the least polar here, and the one that is the most polar is going to ride the polar water up the paper as far as it can before it is deposited from the mobile phase, the polar solvent, onto the nonpolar paper. So whichever one it stays with the longest, the guy who rides the solvent the longest has the same polarity as the solvent. The guy who gets out of the solvent quickest is the guy who has the same polarity as the paper. Also, you can look at, they haven't asked a question like this in a long time, but just in case. So here's the water, here's the original line, this is where the original paper was. And if you watch that little video of it actually happening, you can see obviously the ink from this guy is going to have to slowly grow up the paper. It's going to start out all together, and as the solvent, the water, climbs up the paper, the different dots are going to spread out until you get to some point at which you decide to stop the thing, and that's how far the water got. It is called the solvent front. And so maybe you have one guy here, and one guy here, and one guy up here. If you had stopped that sooner, let me try to draw, and this is, not going to be great, but if you had stopped the solvent sooner, you might have one guy here, one guy here, and one guy here, and then this would be your solvent front. They're going to make it a certain percentage of the way to the solvent front, regardless of where the solvent front is located on the paper. This is called the RF factor, which is retention factor. You would measure the distance from this line to each one of these guys, and then the distance to the solvent. The retention factor is distance to the dot over distance to solvent front. If you're heading to that first dot, the distance from where it started to this first dot divided by the length of the the solvent front, the length from the beginning to the solvent front, should be the same as it is down here. If the solvent front stopped sooner, this distance to the first guy divided by that should be the same fraction. Same with the most polar one. The distance from here to the solvent front, so this number divided by that number should be the same as this number divided by that number.